Well, then this thing is
direct-
sexist. How does it know what I look like?
Right now, we're all colors, All right. Let me share my screen, and I think we'll get started.
And share it to YouTube?
Yes, I will share it to YouTube. Well, if I share my screen now that we're doing YouTube live,
We are live. Fancy that.
Yeah.
So the way to change your avatar? Okay. We're live. Never mind.
Yeah, tell me later.
Let me share my screen. That's me recording, accidentally recording stuff. Should keep that on mute. Can you guys hear me through YouTube Live? Just making sure, because I have it recording.
Let me pull up the stream.
Thank you.
Do you have it public?
Yes, it is. Share screen. Dang it, how did I share? Oh, there it is. Left lower left panel.
I don't see it public. Oh, there it is. Live now.
All right.
Yep, can definitely hear you through YouTube.
Yay. All right. So I guess we'll get started today. Sorry we ran a little late for folks who are just joining us on the live stream. My name is Ron Vadum. Welcome to another CL study group. Today we're going to be talking about profiling Lisp programs. Common Lisp has not necessarily part of the standards, but definitely a lot of Common Lisp systems provide utilities for profiling programs. The efforts of today and the focus of today is going to be probably SBCL, as well as some hooks that Slime provides, not Sylvester, because Sylvester actually took out some of these functions because they were so vastly different between the different Lisp systems that Sylvester focused on some other aspects rather than hooking into profiling utilities. Although at some point, I'm hoping that they will add some way of hooking in to different profilers in different Lisp systems in a cross Lisp manner, so that we don't have to focus our efforts into figuring out the different packages for the different Lisp systems that we're using. To start things off, I'm just going to, give kind of a brief overview of the profiler that I'm familiar with, which is the SBCL deterministic profiler. Now, SBCL, that is Steel Bank Common Lisp, comes with two different profilers. One is called a deterministic profiler, and the other is a statistical profiler. Now, the difference is the deterministic one is a very, very simple per function profiler that folks who may have used like gprof or other utilities like that would probably be familiar with. Basically, it goes through and does a per function call collection as you run the program execution for functions that you've actually told SBCL to profile, and then it will create and generate a report that you would see things like, how much time it's been spent in this function. Was there a significant time in the function where it ended up doing some garbage collection and some statistics like that? What Slime did originally is it added a couple of nice little utilities to hook into that deterministic profiler, which is what I'm going to, start with today. To get things started, I have a little like dummy program here that really doesn't do much. Obviously I have, two functions here. One is just a range function just from folks who are coming in from Python. Like when I early on started doing Lisp, I actually almost ended up writing this always just because I was like, okay, I know what I'm doing all the time. I don't like seeing this, loop to create a collection. I just want to do a range of values. Really, this is a very idiotic way of doing it. There are better ways of doing it, but I started out with this function to kind of like, show things and how the profiler kind of works. If you guys are using Sly, what you want to do is you want to first use, if I remember correctly, require SB profile to actually get the tools, right? No. What was it? It was SB profile or SB prof. Which one was it?
I think it's SB Prof.
SB
Yes,
prof.
that would be correct.
Acquire SB prof. Is it already loaded? Now I'm kind of curious. 1 second. It may have already been loaded into the Lisp system. Sometimes SBCL loads some stuff that, nope, it's not loaded.
The
So,
deterministic profiler is already loaded. You don't have to do anything with that.
oh,
Oh,
okay.
that's right. It's SBS Prof for the statistical profiler, but the
Yeah, the
deterministic one is
statistical one you do have to load.
right.
But deterministic
Okay,
you
that's
can
what I
just start
thought.
using.
Okay. Okay, so let me just do this. So for folks who are using and wants to use a deterministic profile, you would have to use SB-profile to actually access the API. And let me just show you what the API provides, and we can go through each of them. There are 4 functions that this provides. Profile allows you to provide a list of names. And it will tag those names. That is, it will set itself up to actually do some collection to run some profiling on it when you actually execute those functions. If it can take 2 different types of arguments. If the name is a function, so like, let me go back to my original thing here, and we use, say, let me just load this guy up here quickly. Okay. Okay, and I swear, sometimes I wonder if it's just not paying attention. Okay. I've compiled two functions, and I now want to profile, let's say range. You could just specify the name range, run it, and now what it does is behind the scenes, it checks to see if range is in a list of functions that are already being profiled. If it is, it will unprofile it and profile it and set it up for profiling later. Now, the reason it does this is it keeps track of the actual function object that it's about to profile. So it needs to actually replace it. So for like function redefinition, it needs to go back and unprofile that function object and then start up a new entry with this new symbol name and its current instance of the function object. So if you see this warning here, range is already profiled, so unprofiling it first, that's basically SBCL recognizing that you may have redefined the function, and it's just, erring on the side of caution, and it's unprofiling its previous instance and re-adding the entry.
One thing to note, if I may, by
mhm.
using a symbol given to profile, you're telling SBCL to profile a specific function. By using a string
Right.
in capital case, you're telling it to use any function that's given that name, like a generic function that could have multiple methods and stuff like that. So I usually use strings rather, just to tell it to use everything.
But wouldn't that make a difference though? Like here, you like if you specifically use, say, like range like this, I'm assuming is what you're suggesting. Would it actually recognize it? This is the error that I tend to get. Like, this is basically saying that it's not a package, can't find it, so it can't actually profile it. So I'm guessing that you'd have to. This would be the profiling tutorial, I guess. So it goes and grabs everything in the package, and then, yeah.
Oh, I'm sorry. Yeah, I totally said that wrong.
Yeah.
Yeah, a string is any function in the whole package. You're right.
Yeah.
So the string should be a
So
package. I'm sorry.
Yeah. So the symbol names, just to kind of elaborate on what Michael was trying to say. Basically, profile allows you to specify the package name or a specific function. Now, if you specify a specific function, like I did earlier with range, then it must be a symbol, so that SBCL actually looks up in the symbol table and actually checks to see if it's been defined, then checks to see what if it's already been profiled. If it's being profiled, it will then unprofile it, grab the net instance of the function object, and then add it to its profiling table for collecting statistics on. Now you can actually go ahead and run unprofile something if you know fully well that it's going to be dependent upon some other sub functions inside your code. So if you're calling a bunch of other functions internal to this top level like function call, you could unprofile a specific thing. Like in this case, like let's say that I don't want to actually profile sum, but I want to profile just range. I can actually go ahead and say SBCL unprofile, and it will go ahead and take it out of its profiling table. And when you now run, let's say some on some simple function here, let's go ahead and say x. What did I just mess up something here?
You didn't spell lambda correctly.
Ah, dang it. Yes. Thank you. And if we want to run, so we just executed this function, which goes through and just sums, a bunch of 10 integers, and it's not going to, the results isn't going to be anything spectacular. So, and let's say that you want to have a report, you could do SB profile report, and you could just with no arguments get this table. And now that we unprofiled sum, you notice that the sum entry isn't actually in there. It only profiled range. Now let's talk about this particular table. You might see some of these columns. Some of these columns are fairly obvious, but some of them are not. It gives you the total seconds per call. This is kind of the standard thing that a lot of different profiles give you. It'll tell you how much time it kind of spent inside the call when it's doing some stuff. But in addition to that, it tells you how many times the function was actually called in this particular function. How much time how many different calls to cons did it actually do, and ultimately it will give you well. Did it do a lot of garbage collection? That last column there is particularly useful to recognize whether or not you spend quite a bit of time collecting garbage because you may have been consing too much inside of the function, which was forcing a pause for the garbage collector to go in, and that will also increase the time spent in that function, which also will potentially increase the total time of your execution, your program execution. Now, as was said earlier with our mentioning of the statistical profile already, I'm just going to briefly mention that while this is kind of naive in how it actually does its statistics, the deterministic profiler, from my experience, gave you some of the more obvious things, like the glaring things that you didn't notice in code review, but now when you ran it, you recognize, oh crap, I did something wrong. This could be actually be made more efficient, and you could find some of those, by running, this profiler fairly quickly. Now, what Slime did is it took this deterministic profiler and every function that I just showed you here, it gave you the ability to actually call that directly. So like in the case of, tagging a particular function for profiling, you could just do meta x slime profile f definition. And you could specify which function you want. Can everyone see my mini buffer?
Yes, it's very clear on Jitsi. No problems reading it whatsoever.
All right. So as soon as I typed in sum and to that profile unprofile section, notice that immediately it gave me a response saying that sum is now profiled. So now if we go and run that, function call again and then run the report, you'll see that, we've added sum to our things. But notice also for folks that what profile did, the deterministic profile did, it actually collected more information on range. It said, oh, range has been certainly called twice. So now this might actually confuse certain folks from other profiles. Oh, I thought we ran another, program run. This is actually the total report for the program execution up to this point in the Lisp image. Now, if you wanted to clear that, you would have to do first something called reset, which in SB profile, it's just SB-profile : reset. And I don't think you need to specify a lambda list. No, you don't. And it'll just go ahead and reset all that. And then if we run, this again, run the report. Sorry. Let me go back, run this, and run the report. You'll see that in this current run, sum and range are appropriately saying that sum called range, and range actually ran certain things. Notice that obviously in the case of sum, we were consing a little bit. So although it didn't give us any effects on garbage collection, we did actually incur a little bit of a spatial increase, and that makes sense given the fact that if you look at the function that I wrote, I actually am map carring on the range, so I'm creating another list from the list that was already provided before it goes in and does the reduction. So there is going to be some consing there. So I expected that, so it's not a big deal. It's not actually causing any major issues. I'm not actually worried about that. Everything that I've shown so far does have an analog, like I said. Slime, toggle, profile, F definition, profile deals with defining a function definition that you want to profile, unprofile. You can also specify slime profile package, which actually tells SBCL which package that you want to profile. It also asks whether or not you want to only record the most common callers. So I usually just say yes, and I usually also want to profile some of the methods if we define, any sort of methods. And again, as you can see, because we already tagged those two functions as profiling, it gave us a warning when it was trying to actually profile that. Slime also gives you this nice convenient method to unprofile everything. So now if we ran reset and we ran the function and then we report on it, you notice that nothing's actually being profiled, so there's nothing to report.
By the way, unprofile with no arguments also unprofiles everything.
Oh, right. That's a good point. I should actually show that. So we could do this. Let me just show this to you guys. If we run it, you see that things report. We unprofile everything. Now, if we reset first, then we run our function again and we run the report, you'll see that there's nothing there. I kind of noticed earlier that somebody has a YouTube stream kind of running in the background. Can you guys put that on mute? Thanks. What Slime also gives you the ability is if you weren't sure during the course of your profiling whether or not you tagged a profile, tagged a specific function for profiling or not, once you actually set up something, you can actually run Slime profiled functions. And this is the equivalent of, I think it was SB profile if you don't specify any provide, yeah. So I'm going to show you both. As first Slime profiled functions will give you a list, as you can see in my mini buffer, of all the functions that are being profiled in this package. You can also do the same if you do sp profile-profile and don't provide any arguments. It should give you the list of functions that are being profiled in this package. And then, of course, there are some other niceties that Slime has that I couldn't find the exact equivalent, like stuff that I'm not. This is one area of the actually SB-profile thing I'm not familiar with that I'm hoping others are. But there's a function called Slime profile by substring where it does a regex or something. And it figures out, what for a given package or set of packages, if there are any functions that match that call that you're looking for, it'll go ahead and tag it for profiling. So if you have different types of summation functions across different packages, you could literally just go ahead and hit enter here, and it will look up all the packages loaded in your Lisp image, and everything that matches that string or matches it or contains it, I think, it will go ahead and profile that. I thought that SB profile actually goes ahead and does that, but I don't believe it does because we saw that earlier. If I'm wrong about this, I think let me know. Michael, you were going to say something?
Yeah, the profile function, or
yeah,
it just takes an actual, explicit symbol or list of symbols,
okay,
or package, or
all
list
right.
of packages.
So
you can specify multiple packages too with that.
So you can actually go ahead and specify. Oh yeah, you can specify a list of packages here, right? Absolutely. And it will go ahead and match all the profile all those packages.
Could we like, if we have time, could we load up like an actual project such as our map generator or something and run the profiler on a whole project just to see what a given output would look for like
Oh, certainly. Give me just a minute. I need to set up one thing, which is unfortunately I'm running this in a different dist than my original setup, just because of the fact that as I mentioned to you earlier, I had some issues with Sylvester when I was starting to do stuff with profiling. But certainly, give me just 1 second. I'm going to just do a symbolic link to the map generator project. It's in a different quick list dist.
Hopefully that hasn't bit rotted all the. Yeah, that was over a year ago we wrote that.
I've run it relatively recently. It seems to still do its job.
Okay, there's MapGen and MapGen latest. I think I'll just do MapGen latest. That is okay. Let me go and see if I can load this guy. QL quick load EFP MapGen. Yeah, that's what I thought. Give me a second. There's a couple of things that I need to go and. All right, and I think I need the parser library too as well that we built for it too.
Parser should be built into it, I think. I'm pretty sure we only need utils.
Okay, give it a second. Let's load this sucker up and then.
Oh no, that doesn't use the parser. Pretty sure anyway.
All right, so we got everything. Let me load up in quick Lisp local projects AFP MapGen. There's a top level function that you guys wrote. I think it's in.
It'd probably be make stage, if I'm remembering correctly.
Okay.
Yeah.
Okay. So what I'll do is I will profile just the entire package here, the AFP MapGen package. Yes. Okay. So now let me
That
go.
looks like all the actual functionality is commented out.
Oops. Did I get the
Yeah,
latest one?
you must have not gotten the one on GitHub.
This should be the one from GitHub, but let me go and look. Give me a second.
Have you pulled recently?
Well,
Not
if there's
recently.
one called latest, that's not the one in GitHub.
No, that was just me. Because I had my own version, I was following along, and then I had yours, which is from GitHub.
Okay.
So that's the reason. Let me just go ahead and maybe start Lisp. All right. And I pulled the latest. Did it actually load everything though? Oh. There we go. That's it. Okay.
Yep, that looks complete.
Compile error.
Oh, fun. Do hash keys is not found in the AFP utils package. You need to update AFP utils.
Okay. Give me a second. I will abort.
Oh, yeah. We only updated one. That would make sense.
Okay. Give me just two seconds here. I will go to AFP utils and okay, and try that one more time. There we go. Now let me load slime profile package. AFP MapGen. Yes. Okay. And then I need to make the stage, which is AFP MapGen make stage.
Make something large enough to give a good profile. Pass in colon width and colon height. Make them something non-default, like 150 by 150 or something.
Have to be odd, don't they?
Yeah,
150.
they have to be odd. 151.
I'll just do 155.
Okay.
There you go.
That works.
All right.
Profiling slows down everything.
Yes.
Oh, I forgot
Well,
about
for folks who are going to be like, why is this stalling? It is not stalling. It is collecting stuff. All right. So now let's go ahead.
Nice thing about the statistical profiler is it has much less overhead when you're actually testing stuff.
So we will go ahead and show the differences.
Yep.
And here is our profile, our awesome generated profile. Okay. Notice,
Go to the top.
and we can actually go down to each kernel. Each level. We can actually figure out how much time it's taking. I'm actually surprised that almost everything
so we can
else.
see that.
Okay, sorry.
We can
Go
see
ahead.
that the first one there, uncarve, it's being called about 3,500 times. And it's by far much more expensive than the next one down, which is called 14,000 times.
Right.
So this is a good way to measure stuff like that. You might think that you're calling something only a couple times, but it's using most of your processing time. In fact, in this case, 8 times higher.
Right. Pay attention to the first column is really what you'd want to do, because that's the total amount of time spent in the function. That's a big thing, because that indicates, this might be something I may need to review just to make sure that it is actually a bottleneck.
And you can see that you're not gonna improve the speed by reducing consing because it's already not consing anything.
Yeah.
But if you do look at the consing column, if you can reduce that any for any of the ones that are contributing a lot of the time, you can probably improve the whole speed of your function program.
Right. Consing is going to be well, it's funny. Depending upon, consing is cheap. It's more when where consing ends up, creating a structure that destroys like locality. So then it obviously it's going to cause some time to actually load things back into memory, which will slow down
Also
your
GC time.
And yes, it will also increase your GC time. But if you can see here in this particular example, almost nothing is actually being affected by GC. Like the garbage collector is actually being fairly spent. I think all of it is 0, isn't it? Yeah.
So yeah, the third one down is probably one that you would, nope, the third one from the top.
Third one from the top. Okay.
That is probably a good candidate for optimizing because it's only called once.
But yet you cons 8 million times in that one call. I was looking at that.
What caused 8 million bytes?
Oh, it cons 8 million bytes. Okay.
Yes.
Got it. All right.
Yeah. Used up 8 megs of RAM.
Jeez.
Maybe not all at once, but.
So really,
So that third one down is 1/10 of the whole program speed. Yet it's only called once. So I mean, if you can improve that just by a little bit, it might help a lot.
It might help a lot in lower stuff, but this uncarve is really, it might even affect this, maybe. I don't know.
Yeah.
So
interpreting profiling reports always requires a lot of domain-specific knowledge.
Right. Absolutely. Well, let's try the statistical profiler. This is the deterministic profile. Let me pause here for a second. If there are questions on the deterministic profiler, like I said, it's a fairly I think it's a fairly straightforward profiler. It's for more obvious situations like this here. Even if you went with the statistical one, I mean, I'm sure you would come up with the same conclusions because these are fairly glaring, obvious bottlenecks that you would have to first address that you could fix without necessarily having to go through the statistical profiler. But we're going to certainly go through it and show you the differences in both speed and the kind of reports it will generate. So, any questions on the deterministic profiler from folks?
Yeah, Ram. Is there any way to get like the call tree with the profiling, or is that the only information you get from the profile, just the raw data like that?
There are different report styles. I don't think we've actually looked at that yet, have we?
No, we have not. Okay, so let's see. I think let me just go ahead and do this here. SBCL profile report. You could specify.
Let me try to remember how to do that.
I think no call list is false, is nil right now. Let's see what that did. Still did not specify anything. Didn't give you the call tree specifically as you were asking. Let me see. I don't think for the deterministic profile, I don't think there's a way to actually.
No, that's actually the statistical one. Yeah.
Yeah. So in the deterministic profiler is really just what you're looking at. I mean, you could limit the results. You can, but that's about it. There isn't anything really like I can actually say colon report limit 10, and it'll only give me the top 10, functions that are really affecting the total performance of a program. But that it doesn't actually give you the call tree as to how functions are being called. When we get into the statistical profiler, because it does the instrumentation, it can give you a better sense of your program execution when you go into the reporting piece. So I guess that's a good segue into actually showing off the statistical profiler. So by
Oh,
default,
there's a note in the. Oh, sorry.
go ahead. What you were going to say?
I was just gonna say if you're using the deterministic profiler, when profiling code that's executed by multiple threads, it says that the consing column is inaccurate, and yeah, that's just something to be aware of.
The consing column is inaccurate in the multi-threaded case.
Yes.
Interesting. I haven't seen anything in. Does the statistical profile handle multi-threading instrumentation better? Have you seen anything regarding that at all?
I really don't use the statistical one much. Maybe Elijah knows better on that question.
Elijah?
I've not checked to see what happens when you use the statistical profiler multi-threading, if I'm being perfectly honest.
Okay.
I wouldn't be surprised if it handles it a bit better, but I'm not certain.
Okay.
It
All
doesn't
right.
say anything about it in the docs.
So that is something to experiment. Folks who are watching the stream, if you guys know anything related to the statistical profiler and multi-threading, please add a comment in the YouTube channel and on the YouTube video specifically, and we will certainly, mention that next time so that we could hopefully help other people who are trying to profile and see some analysis on their multi-threaded programs in Lisp. So any other questions?
No, just one more comment though. If you have an inline function, it's not going to appear in the deterministic or the statistical profiler. Obviously.
Interesting. Yeah, that's for good reason, but that is something to be aware of. If you inline,
Yep.
you're going to essentially erase where it's going to be, right? I mean, it's not. I mean, it's inlined, so I don't think it should show up. But okay, so let's talk about the statistical profiler. The statistical profiler is a package, another extension in SBCL specifically. The package doesn't get loaded when you load SBCL for the first time. You have to go in and add it yourself to your Lisp image, and the way to do that is to use require and load up the specific package name, which is sp-sprof. sp-sprof comes with some interesting things. I'm trying to recognize one specific thing, which is to do profiling. So to actually profile your code and record call counts, you have to use sb-sprof :profile call counts, and you can actually specify again symbols, or you could specify the names of a particular package. We're going to go ahead and in this case specify a particular package. We're going to go ahead and specify AFP mapgen here. If I can type. It will check to see if it's loaded and return nil. If you try and pass in a package that isn't loaded into the image, it will throw up a condition saying that the package isn't loaded. I'll give you some options. To actually go ahead and profile, though, you have to use the width profiling function. At least I don't know of any other way of actually using this. this guy. You specify here the maximum samples that you want to run. For the sake of simplicity, and I think it's going to actually slow down if I do it any more. We're just going to take 10 samples. So this is going to be a really dumb thing. All right. You have the then ability to report. There are different types of reports. I've used flat. There are other options though that you can certainly use too. I'm wondering, has anyone done anything other than flat in the report here, guys?
I have. It's just been too long. I can't remember what else is
Yeah,
available.
it's been a little while now.
Okay, so give me just 1 second. I'm going to pull up the documentation here since I don't remember. Okay. Report. It can be either flat or graph. So if you use graph, you get the call graph and a flat report. If you don't, so we'll go ahead and use graph because Michael Gargano, you mentioned that you'd like to see a call graph. I'll go ahead and also say that we want to show progress so that we know how long it's taking. And let's see, what other thing would I want to do? Since we're doing maximum samples, let's go ahead and, let's say loop. And we're going to go ahead and run AFP mapgen make stage again. And we'll do the same collection that we did earlier on a 155 grid. Now, this is going to go ahead and run this tab and collect 10 samples of the execution. And might take some time before it actually gets done. But then once it's done, notice here we get a flat report, but earlier we also get the call graph, which is kind of funny. It's mixing up the mapgen collection as well as the some stuff from Swank in here. Interesting. All right. Then, yeah, it gives you the call graph. It'll tell you the function that it is. Here, as you can see, if it's an anonymous function, we'll go ahead and label it as such, how many times it was called, and so forth. It also gives you the percentage of time it's spent in that function too as well. This is kind of the majority of the collection, I would say, along the lines of this other section, which is in, yeah, that's it. There is a major, it just periodically goes and shoots out. So the major piece of the interaction with respect to our mapgen program comes and falls into this kind of like area, according to the statistical profiler, with just 10 samples. Now you have to run this for significant, I would say, for a couple of times just to get some meaningful, collection results in the statistical profile. Out of 10 times, it's really, not going to give you something, realistic. But it gives you some, again, like with respect to the deterministic profile or some obvious areas where you'd want to, go and make some changes and see where your bottlenecks are. Comments from other folks who have used a statistical profiler.
I really don't use it that much.
I mean, I've worked with it before. I found it helpful for tracking down call graph stuff.
Oh, sure.
I'm actually a little distracted at the moment, I admit, because I'm looking into something that I keep meaning to tinker with. It's related to the statistical profiler. but I don't know if it's ready enough to actually show. So so one of the there's a visualizer for the statistical profiler implemented in McClim.
Oh, really? Nice.
Yeah, it's under a lot of devs still. So, but I mean, I can try demoing one of the branches that I've seen before and has a nice little interface.
That would
If
be
you're
fun.
curious.
Oh yeah,
I haven't tried demoing it myself before, or at least not in a while. I think I have demoed it once. So you know, it'll be an experience for all of us. But I'm up for that if you're interested.
I'm certainly up for it. Other people in the call, would you guys be interested in looking at this visualizer?
Sure. It wouldn't be a stream without McClim.
Yeah.
Exactly.
I'm going to keep pushing interest on it until it becomes a thing. Okay. 1 second. There you are.
Hey, a lot of
QL.
folks are interested in McClim, man. So you can't blame
I'm
us.
not knocking on it or anything. I think McClim is great.
Yeah, I know. It just still needs a lot of work.
Yeah.
Give me a minute. Wow, Quick Lisp is struggling a bit. Do you mind if I take over the stream for a bit then?
Go for it, man.
Cool. Application window.
If you show me your
DLC
screen,
thingy.
I will go ahead. It shoots up into the live stream. So hopefully now it
Oh
shows
boy,
your window.
that's pretty tiny.
Give me a minute. I need to adjust the size of my little thing here. Where's the info? 1920 by. Oh God, come on.
That's actually sharp.
See if that helps any. Okay. Yeah, I can increase the font size. That's not an issue. Zoom frame.
Keep going. Keep going.
Keep going.
Yeah.
Right. Yeah, that's good.
Okay, cool. So I did that. Let's see if I have no.
Can everybody else read that?
Yes, I'm just waiting. There's a little delay on the stream, so
About 15 seconds.
yeah. So if you just give me a second here while you're still loading your stuff, I can actually tell you. Yes, that's perfect.
Okay, good. Let's see. Do I have AFP map gen at the latest? Fetch stream. Cool. Yes. And let me just make sure that I have the latest AFP utils. Cool. Before that becomes an issue. Okay. So apparently I can do something along the lines of et make thread lim dot flame graph. Oh, well, okay. So I guess I need to already have the profiler have a profile done yet before it'll let me visualize. Okay.
Certainly.
So, huh?
That makes sense, right? I mean,
well, I was hoping that it would just pop up in sort of a background mode, but and wait for me to profile something so that I can then but I guess it's just I'm also not actually using the branch with the absolute latest number of commits on it, because that one doesn't have an obvious little bit of demo code for how you launch the thing. So it's possible it's actually, much nicer and more advanced than what I'm about to show you if you actually know how to launch it properly.
Certainly, that makes
But,
sense. I mean, I think that documentation would probably take some time too.
Yeah. So let's see, where was I? So start profiling. Probably want to make sure I'm doing the right thing here. Then AFP map gen.
Make stage.
Width 155, height 155. SBS prof stop profiling. Seem reasonable to you guys?
Certainly. Now, the start profiling and stop profiling is getting a single sample, right?
I forget offhand, honestly. But let's see what that gives me. Okay, so that's crazy so far. But so I got here's the flat profile. Here's the graph. I'm guessing these are each different samples I can click on. There's a way to zoom that. Okay, use the slider on the left side of the view to zoom in and out. Okay. Depth limit. So I can, let me do that. Okay.
That's actually only showing Sly and Slink, but it's not actually showing calls in the flame graph for AFP MapGen at all.
Well, here we are. Make stage.
Okay.
Erode dead end. Uncarve. Interesting. Okay. So I wonder what other stuff I can actually do. Okay, so I can just select traces in here and okay. Oh, so it does actually have. Oh, I can set an interval. Okay. Okay. Did not like that.
Boom.
Return to the application command loop. Abort. 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 It's gone wrong. Okay.
Danger.
Yeah, apparently I don't know what I'm doing. I mean, I didn't really, I'm not really surprised by that realization, but apparently I don't know what I'm doing. Okay, so let me take a look at so like I've looked at screenshots of this that show so one thing that's interesting is that this seems like okay, so let me start profiling. Yeah, did not like that either. Okay. That's fun. Okay. So I'm recording now. Something.
Okay.
Apparently. It's capturing stuff.
So it's getting time points.
Yeah.
Okay.
And now I think if I head back over here and I just run that, it'll flame graph. Will it show that anywhere? Okay, so it does have that stuff. So it has like all of this. So I wonder if I can like select a region somehow. So like, does help do anything? No, it's no help. Okay, so like, there's clearly this set interval command. I just don't know how to use it. Like, what if I say, okay, set interval start. I'm going to just take a look at the code behind that command real fast.
Go for it, man. Could you show us the code too? We could.
Flame graph source. Again, keep in mind, like, it's entirely possible that this whole thing is actually much nicer and much more functional at this point, and I'm running a slightly old version that's got weird nonsense in it.
Certainly.
So,
That's fine.
but commands, let's see. Zoom, disassemble, start recording. Interesting. Okay, so it does a start profiling on all threads, and then it grabs samples. Interesting. And then, okay, so where's the interval stuff? Zoom, reset view. I don't see interval stuff in here.
Just do it. That's the whole project.
Ah, interval.
Yeah. Mm-hmm.
Okay, so you can actually interesting. Fine, flame graph command, com move interval. Okay, sure. Okay. Sure. Right, yeah. It's like I'm fairly certain that if I get an interval instead of just a single sample on here, it'll actually show me an actual call graph, or not a call graph, you'll see what I mean. It can show multiple. I've seen screenshots of this showing multiple functions horizontally on a single level. So that's why I keep trying to set an interval.
But is there a start in the interval? I didn't notice that you.
Ha ha ha! I think I made it. I think I made an interval object.
How did
I don't know what I'm doing.
I didn't notice that.
I don't know what I did.
Because when you specified an interval, I thought you would have to go into some sort of timeline and specify, a start time and an end time, and it'll just create it for you. But I didn't see.
I would have expected that as well.
I didn't see you do that. That's the reason why. Just like suddenly there's a block or a range. Try set interval start again and go into the timeline and press
move interval. by 14. Aha! I moved the interval.
Ooh, there you go. Okay.
Okay.
I think we're getting somewhere.
So apparently the drag and drop stuff isn't quite there yet. But let's say if I set that over to 30, let's see, where is that? Is that not quite there? That's not quite where I want to be. But it looked like if you have multiple samples in the interval, right?
Yeah.
What does that purple block represent?
Those are all of the samples that it took of the map gen.
Okay, move sample by -4 then.
Yeah.
Yeah.
Yeah. Go right around like
Move
40.
that interval do by -4. Yes. The thing is, I'm not showing the right thread now, but I wonder if I come over here, can I click on that thread to show? Oh, no, I am showing the right thread. There we are. Haha. I have the power.
This is the call graph and all the functions associated. That's actually pretty cool.
Yeah. So make stage.
You can probably zoom that in a little bit. Maybe.
Yep.
Yeah, which calls call rooms and
Mm-hmm.
Oh, interesting.
Yeah, so carve rooms, carve corridor cell.
that's pretty neat.
Yeah. So I know for a fact that like you could set up. There's something I can click on there. What is that? Keep seeing my cursor change. You guys can't see that because you don't see my actual cursor right now, but I keep seeing my cursor change when I move over that little spot there. I feel like there's clearly something that's not quite, because like when I looked at the code for this, there's a drag and drop translator. It's right there. That should make it possible for me to grab the interval and drag it.
Yeah, but I don't think it's working right now.
I agree. I just don't know why. I don't know. It may just be a little broken at the moment. But yeah, so this is the sort of thing that you can put together given some time tinkering with Clim. I wonder if I click on that, if anything happens. It does. Oh, I zoom into that call. That's neat. Interesting.
How do you zoom into that call?
I clicked on it.
Oh.
So I assume like right clicking would bring you back.
Maybe? I don't know. I don't know how any of this works. I have no clue what interactions.
Pretty interesting.
Let me see what let me look at the code behind Zoom call, because I don't think that's in here. I think that's in commands. We've got select trace. Oh, there's a reset view. Okay. What happens if I reset view? Okay. Okay. So that takes me all the way back out. They could bind that to a key. Just not bound to a key at the moment. I don't think. I may have missed that. No, that's not where I want to go. I want to go to commands. There we are. Is Zoom call? Is reset? Ah, okay. So if I click on the blank area, that should reset the view. Interesting. Yes, it does. Interesting. So I can like go and I want to look at that and then go, okay, back out again. Neat. Yeah, so you can be like, okay, I want to look at what's inside here. Cool. And of course, with enough samplings, right, you could get a much more detailed call graph than what we're even looking at here. Let me kill that. And we have a bit more interesting. Let's see, SBS Prof. It's been a while since I've used the statistical profiler. I actually also want to know why Company isn't doing its job right now. Much better. Okay. Okay.
Yeah, I was wondering why you were using CapF.
Yeah, well, shush. Okay. So
With profiling, actually takes a lot of different arguments.
yes, it does.
Documentation.
1 second. Okay. Actually, what is the sample interval? SBS prof sample interval. What are you? 1/10 of a second. Seems reasonable enough.
1/100th of a second.
You're right. Yes. Sorry. Okay, so let me set the sample interval to 1/1000th of a second, just for fun. Mode, CPU,
Sample, max samples.
yeah, let me say max samples. Let's see, how long did that take to run, you think? Let me just do 10,000 samples just for fun. 10,000 samples at a sample every 1,000, so 10 seconds. Sure.
Make sure you pass reset T.
True.
Ooh, I wonder what statistics. Were we running in CPU profiling mode earlier? No, we weren't. We were running, I think, in time profiling mode.
I mean, either way.
No, it's fine. No, I'm just wondering what additional information CPU profiling mode would give us. That would be pretty cool.
Maybe if you wrap that in a thread, then you won't get all the noise in McClim because
You're
could
right.
pass
Actually,
a thread.
you're right. I wouldn't. SB or BT
Make thread.
thread lambda.
Yeah.
Okay. AFP map gen make stage.
Well, you have to pass the threads argument.
No.
Otherwise, it does all.
Start profiling defaults to all threads. Okay. So defaults to the current thread. Yeah. Yeah. No, you don't have to pass that.
Okay, good.
Because I only want to profile that one thread. I'm going to want to know when this is done.
That's not going to be done. It's going to loop forever.
No, it's not. I set max samples, remember?
Oh, true.
Never do this. Terrible idea and not thread safe at all.
Oh, threads and streams. Yeah, definitely not.
Five, six, seven. There it is. Oh wait, no, that's something else. That was it noticing the. There it is. Okay, it's done now. Okay, now what happens if we all open the flame graph? Wow,
Boom.
that's a lot more samples.
Yeah, it is definitely a lot more samples.
There we go. Much better. And actually notice the interval is covering the whole thing now for some reason. Okay, so I can like be like, I only want to look at what's inside make stage.
That is impressive.
Mm-hmm. So here are all of the calls. All of the calls.
And you can figure out some of the Ooh, that's really
Yeah,
nice.
so you can see here, you can see how much time is spent across this interval in each of these things, right?
Whoa, what's delete?
It's a CL function. The statistical profiler captures everything.
Okay.
Right, so you get standard functions, you get SBCL internal functions, you get stuff in your package, you get stuff in other people's packages. Everything. Apparently, we spend a lot of time deleting stuff from lists or sequences in general.
Yes.
A lot of time. That's something maybe we want to look into. Here's some deleting.
55% though. That is significant.
Mm-hmm.
That is very significant.
Oh wow, look at that. It's uncarve. Uncarve calls delete all the time.
Yep.
That answers that question. Right, so the neat thing is that the way this renders, right, it shows you not just that a function called another function, but how much of this function's time, or like this function's time, was taken up by that function. Right?
Right. I mean, that's the benefit of the flame graph, right? Because you can actually see where the slice in which
We can see how SBCL's intersection works.
Right.
Or remove if not works, that is. Oh, right, we passed in intersection to remove if not. Yeah, that's right. Yeah. Member. Yes, zoom.
So member calls a lambda, which then ultimately calls
intersection.
Intersection.
Apparently, intersection calls itself fairly often too.
So it's a recursive operation. Okay.
Apparently.
That's awesome. That's pretty cool. That's something I learned today.
Well, I think. Yeah, I don't know. That's neat though.
But
yeah. That is a lot of samples. But yeah.
Very
it
dense.
Called make stage 9,948 times. I just noticed that.
That's impressive.
Well, I mean, It's also weird, actually, now that I think of it. Because I feel like it can't possibly have been that short of a process, could it? I mean, maybe. Anyway, So this is the statistical profiler for you. Oh no, that's right. Hits isn't calls. Hits is the number of times that function showed up in a sample. Right. I always forget that everything in the statistical profiler is about number of times it showed up in a sample. Right. So like this being so much smaller than that is saying that, you know, in this many percentage of the samples where we saw this one, it was in the middle of a call to this one.
Yes. So wait, so delete calls equal there, right? And then
Yes.
equal calls delete again is
No.
the thing in that, right?
No.
Delete calls delete sometimes.
Oh, okay, got it.
Yeah, this is saying that delete sometimes calls delete.
But okay, got it. So it shows all the function invocations that it has in the layer before it. I just wasn't sure how the slicing was kind of working there.
Yeah, the slicing is literally this called that, which 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 called that,
and so forth,
etc. Right? And basically what this is saying is that there was some sample, at least one sample, in which the stack looked like this.
Yeah.
Right? If you draw a vertical line through here, there was some point during the execution of your program, at least once, when the call stack looked like that.
Right. Okay. The 10 hits there in that delete call, that means that within that single vertical line, though,
there were 100 samples that that looked like that.
Okay, got it.
There were 100 samples where the call graph looked like this.
Got it. But with EQL, can you go to the EQL? Oh, 895. That's why it's significant. Okay, got it.
Yep.
Yep.
But a lot of the time, when it found delete at that spot in the call graph, it wasn't it was at the top of the stack.
That's good.
Or the bottom of the stack, depending how you look at it. The tip of the stack.
Yes, it was at the top of the stack, right? It was the top.
Sure.
Remember,
it was the most recent thing put on the stack.
Right. Exactly.
But yeah.
This is actually a very nice project. And what is this project name again?
It's Clim Flame Graph.
Clim Flame Graph.
Yep.
I will post.
This is specifically the future branch of it, but there's also another branch called Advice Backend, which looks like it adds support for multiple backends of profilers, if I'm reading it correctly.
Nice.
Yeah, but I can't quite tell how to start it. Like, I'm looking around in there, and I haven't quite figured out, like, what one does to actually do the thing. So, you know, I may have to ask something on the Clim IRC at some point, see if I actually don't know how to pronounce his name. Has any idea or has any suggestions about how to actually use the thing? It was updated 2 months ago, so you know, it's not like it's
actively developed. It's just getting.
It's actively developed, but slowly. They have other stuff they're doing.
Right.
But like even the future branch, which was like from back in February, was last time the future branch was worked on. The advice backend branch is atop the future branch, as far as I can tell. But this is the future branch, and it was worked on back in February, and so, you know, even this is already, like, it's a little buggy. The rendering is a little funny. Although I think actually what you're seeing there, or can you guys see that? I'm curious. Yeah, you guys can see that. I think actually what you're looking at there is nonsense because of my little mouse extension. So what happens if I turn that off? Want to see? Does that fix it? Yes, that fixes it. It was that was me. The nonsense with the colors being wrong, that's the little program that I was running to make it so you guys could see my mouse.
Gotcha. Okay.
That wasn't it. So just so we're all clear, the color nonsense you're seeing here is actually my little mouse program.
I don't see any color nonsense.
So you don't see the trail
I see.
behind my mouse?
Oh, now I do. Yeah, I saw that earlier. I
Yeah.
saw a big trail over your
Yeah.
listener.
Yeah, so that trail is just my little mouse program being dumb. It's just, I prefer for you guys to be able to see my mouse when I'm doing visual stuff because I like to point at things. Anyway, so yeah. So this is the sort of thing you can make in Clim right now. It's clearly, got rough edges and the interface isn't exactly user-friendly at first if you don't know what you're doing. But, it does the thing. And they could definitely fairly easily, I'd expect, add more functionality. So, like, I think I can set interval and select that interval and then be like 8. And there we go. Yeah, so that's how you're supposed to do that. So now the interval goes from there to there. And there are ways they could make that more intuitive. There are ways
you
you
did
can.
set interval start, and then you did set interval end, right?
I haven't done set interval start on this one yet.
Okay.
But yeah, set interval start. Then I have to click on the little box, on the interval box.
Right.
Right? And then I can say set that to 2. And now the interval starts at 2.
Yeah. Got it. That makes sense. Because if you have
Yeah.
multiple intervals, you could then, sub.
Right. Although I don't know if this supports multiple intervals right now anyway, so I don't know if it really matters.
Well, I don't know if it matters in this case, but I'm guessing the reason
right.
they designed it is so that you could have multiple.
Well, actually, I'm fairly certain that the reason that they defined it that way was so that they could add, they could make the interactivity of the system based on like interacting with the box that's on screen.
Yeah.
Instead of doing it down here in the command menu or down
Mhm.
down in the little command, the interactor.
Yeah, the interactor.
Yeah, instead of running the command by hand in the interactor, they ought to be able to add some presentation to command translators or drag and drop translators or stuff that are related to that box itself.
Right.
That would invoke these operations. In principle, they could. It may need some reworking of the way the code does its stuff. I'm not certain, but yeah. So that would be why I would have set the commands to take the interval object, because that just makes it easier to write the translators.
One quick question.
Mhm.
Why is the bar orange this time instead of purple?
I have no clue. I think they just have something that picks colors.
Okay. I thought that was significant in some way.
If I were to take a wild guess that there's just something in there that picks colors for them, or they have a thing that picks colors, and it's just so that
Oh, it's probably because the thread is orange in the graph,
maybe.
whereas make stage is purple.
I have no clue, if I'm being perfectly honest. I have no clue how this whole thing would work if I started having multiple threads.
Can you click on unknown component right above make stage? What the hell is that?
That? It's probably something internal to SBCL. It's the thing that, or it. If I were to take a guess, that's so like you've got the Bordeaux, the SB thread initial thread function trampoline, Bordeaux thread binding default specials. So that's what's binding my standard out, and then I guess that is as some helper in SB SProf.
Huh.
If I were to take a wild guess. Foreign function call into Lisp. New thread trampoline. Call with mutex. I'm curious what mutex this thing actually needs. Like, what mutex is it getting there? Unfortunately, I cannot see that in this, but yeah. So anyway, profiling. It's neat.
Yes, and the visualizer, I think over time, a visualizer like this would certainly help give a better idea for folks who can't understand like the flat graph or
Honestly, looking like I've taken the time to look at the output of the call graph that the statistical profiler generates, and I did find it helpful once I understood what it was doing, once I looked at it closely enough, and I did that. But wow, it was a royal pain, and it kind of hurt my brain doing it. This
yeah,
sort of thing is much more useful. It's much more obviously visible what's going on.
you can clearly tell based on
Now
the
somebody just has to extend this to for the trace function, because that's a pain too.
Actually, Slime has an interface for trace, or is it Sly? Might be Sly that has an interface for the trace system.
okay, one thing for me to go and take a look at.
Yeah, either one of them has an interface for tracing. Might be both of them. I don't remember. I haven't ever used it, but I know it's there.
Got it. But yeah, I mean, I think that this is certainly a good project that we need. I'm glad that we were able to get an opportunity to highlight, because
Yep.
This is a step in the right direction, in my opinion, for showing off some of the profiles, rather than just the flat report. It's easy if you take the time to actually go through what it's actually showing and how it does, but having this ahead of time will give you at least a nice introduction to doing profiling in general.
Yep.
A project like this. So yeah.
What I would really like is if double buffering were functioning on this, so you didn't see it drawing the bar every time the thing has to redraw.
Talk to the Clem guys.
Wait for the SBL
I'm
to,
sure they know already. It's like they talk about double buffering on the Clim IRC on a fairly regular basis, so it's not like they don't know.
No, it's an existing issue that
Yep.
that we have to solve in the project before.
Well, at the moment, they're currently working on transitioning the CLX backend to use Xrender for performance reasons, and once they have that done, switching to using double buffering will be a lot easier, and they should have a lot better graphics primitives for using backends that do like triangle-based rendering and stuff like that instead of doing pixel-based rendering.
Nice.
This is discussion that they're currently having on the IRC. It's kind of exciting, but apparently polygon decomposition is a royal pain.
Yes, and I think well, it shows there are currently limitations in the CLX backend that are that need to be addressed prior to some of these other additional features, I would say.
And also there are limitations in how the backend API works that need to be fixed before it's reasonable to start writing other backends. I mean, I would argue that that's the biggest reason why we see it's taking so much time for other backends to be developed. It's because the backend API isn't even quite ready yet for all the stuff that we'll want it to be used for.
The backend API, I mean, if you go down to it, right, and you look at Clim backend, I think the CLX backend has some very nice documentation that ultimately says you need to implement these 40 or 50 functions in order to actually get somewhat of a working backend. And most of them is actually implementing particular protocols for the substrate. So I think you have to implement the geometry substrate, the windowing substrate. Forgetting what the other one is. There's 2 or 3. There's like 4 substrates you have to implement in order for your backend.
Geometry, windowing, the medium substrate, I think is one of them.
Yeah.
Because I know that every backend needs to provide an implementation of the medium functions.
And this is and it makes sense given when you look at what is a medium, what is windowing, and what is geometry. These are very low level primitives that Clim kind of assumes you will take care of as part of your backend. So when it does its rendering, it can actually blindly call its own API calls, and the backend will take care of the rest. It's just that when I started looking at it just to see if I can write a backend myself, I ended up realizing that it was difficult to separate between what is considered to be part of the actual protocol that you have to implement to what is kind of application at the application level.
Yeah.
That's one thing I was kind of hoping at some point someone can at least present okay, even though it says you need to implement all these functions, these are actually the core protocols you have to implement. These are application things that you can implement for optimization purposes.
Well, I mean, the other side of it is that, honestly, the API is still in flux, right? Like, the biggest reason why the CLDK backend no longer works is because there was a massive refactor to the backend API back in November.
Yeah.
So and they've just made changes to add a new selection protocol, which is why copy paste now kind of works. Actually, I wonder if I have an updated enough version of Clim that I can show that copy paste works. I probably don't.
What do you mean copy paste up until now didn't work?
Not to outside of Clim.
Oh, okay. So you're saying that copy paste now actually copies to the platform's clipboard, so you can actually. Okay.
There's now a backend API.
Show that off a couple weeks ago.
Oh yeah, he
Yeah,
did.
Okay, I forgot about that. I did.
Yeah.
Okay,
but yeah, no, copy paste was only internal for a while, but now there's an API by which backends can translate copy paste operations to the actual native platform clipboard.
Yeah, that's really
so
cool.
But that's a change to the backend API. So the backend API is like always in flux. And so, and they're still sort of working out, they're debugging CLX, they're debugging the CLX backend, they're debugging Clim, they're cleaning up bits, they're refactoring bits, they're migrating bits, they're coming up with new primitives by which backends might be written, they're coming up with new helper libraries by which you might handle different primitives. It's all kind of in this big process of settling out exactly what it means to be in Clim and exactly what it means to be in the backend and exactly what things need to be in the backend to get everything to work. So I get why Jack Daniel hasn't written the backend API documentation yet, because it's still in flux. Any backend docs that he writes would be out of date fairly quickly.
Right.
So on the one hand, I kind of want to fix up the CLDK backend just for my own purposes. But on the other hand, I feel like that's just going to be a big maintenance headache that I'm just going to have to be dealing with for the indefinite future. And I kind of wanted to wait until things settle out a little bit until that, before I get around to doing that.
Yeah. But so, CLDK is really just a wrap around SDL2, right? That's the one that you were talking about?
Well, yes and no. CLDK is a mess. It's actually presenting its own simplified backend API, where you basically have to provide input events and handle blitting an image onto screen. And it reuses infrastructure from the CLX frame buffer backend, which is a backend that does entirely software rendering inside of Clim, and just blitz that to screen as a single frame buffer operation. And so the CLDK backend basically reuses the machinery of that to present its own backend API that only has to provide some input primitives and handle drawing an image on the screen. From what I can tell, I may be wrong, but this is what I understood last time I dug into the code base. But basically, it's extremely over-engineered and kind of a royal mess. Because it's basically trying to present its own backend interface and abstract over all kinds of stuff inside of Clim's own backend interface. And it's trying to do threading trickery and abstract over that for you. And it's trying to do just all kinds of stuff. And so, on the one hand, I feel like I I don't know if I would want to. I feel like I would, if I want to do this, I would probably end up just stealing a lot of code from CLDK and building a backend of my own. But at the same time, I'm not entirely certain I want to do that until I feel confident that the backend API is reasonably stable and that all the primitives that I would want to be making use of have been written and are reasonably well tested, et cetera, et cetera, et cetera. The other thing, and I guess, Michael, you might be more aware of this than I am. I just see the messages that go by on the Clim IRC from time to time. But 3B does actually seem pretty committed to writing a glop2 based backend for McClim.
Yeah, I've been talking to him on the First Light channel.
Yeah,
about that.
he's been asking a lot of questions in the Clim IRC about it, about like how the CLXFB backend works. It's basically going a similar route to the way the CLDK backend does, which is getting software rendering stuff and then blitting that to screen as a way to get started.
The FB backend, is it going to be? Would it be more performant than the?
No.
Oh, okay.
No.
Great.
No,
Just
the CLXFB backend. Well, it might actually. It's possible the CLXFB backend is more performant right now, but only kinda. Like a well-written CLX backend that actually uses Xrender and does like smart stuff with like some degree of accelerated rendering or higher level drawing operations should be faster.
Okay.
Because the CLXFB backend is entirely software rendering inside of Lisp. And so you can optimize that. Sure, you can get it pretty fast, but it'll always be limited by the fact that you aren't actually taking advantage of your graphics hardware.
Right, true.
Right?
I'm not denying that, but
right, and so like my point is just that the CLX backend, if it's migrated to Xrender, would actually be able to make use of some higher level graphics drawing operations exposed by Xrender that would be able to make use of hardware accelerated stuff internally.
Because
I'm waiting for.
I just want to point this one thing out, Michael, and that is one thing that I'm hoping that, this is probably too early because of it's still kind of maturing right now. One issue that I've seen in the past with, say, using like Qt when I did C++, is they have with the Qt platform abstraction, this ability to like go from, at least in Qt5 now, depending upon whether or not your graphics card supports a particular layer, you could actually write out like, a fallback strategy. So it starts with hardware acceleration. Can't find the graphics card supported with OpenGL. Okay, we'll fall back to DirectX is the angle. And if not, okay, well, we have this DLL that actually does a software renderer for you so that you can still have high performance QML. But it'll still be software rendered, so it's going to be as fast as the CPU can actually do the software rendering for you. So I'm hoping a future where CLX can do or give us the ability to do that kind of.
So McClim can actually already do that with multiple backends, right?
Did it switch between backends right now? I didn't think it did.
Actually, I mean, the thing is that there really is only one backend that's functional at the moment, but the infrastructure is already there to even run multiple backends simultaneously.
I have not seen an example of that. That's probably why I thought it was only running one backend at a time.
The find port operation, right? Which is it's a function you don't have to call because it'll call find port for you with the default port when the first time you try to make an application frame. But if you call find port, you pass the port a description of the connection you want to make, and that includes and that request is or that I forget the term for it. It's like a query, it's like a path, I think is the term. I think the term is path. Something along those lines. But the idea is that includes all the options for requesting a backend. And so that can be things like, for the CLX backend, that can be things like, here's my display number for what X server I want you to connect to and stuff like that. But you can give, but basically the syntax of that, apart from starting with a keyword which names the backend you want, is backend specific, if I remember correctly. And so like you can basically stick anything in there. It's a list that's of all backend specific options. And the idea is there's a default one, but there's no reason why you couldn't have. So basically, when you call find port, that spins up a backend specific connection to some display framework based on the path that you pass if a connection doesn't already exist. And if a connection already exists with those settings, the backend is expected to basically provide that same connection back to you, right? That's why it's find port, not make port.
Right.
And so, but you can have multiple ports. You can have multiple ports at any time. I can make a port that uses CLX. I can make a port that uses CLDK. I can make a port that uses CLX FB, assuming that's still actually functional, which I think it is actually functional as an independent backend, but I haven't tested it.
I tried it a few months back, and CLX FB's demo at least worked.
Yeah, and so you can make multiple ports, and then you can make frame managers for each of those ports, and then you can spawn application frames on those specific frame managers, and so they'll use those specific ports. And you can do all of this simultaneously. You can have as many ports as you like running, and more or less it all works. Like there's some limitations in like multi-threading stuff, right? Like if you can't run multiple threads, you can't exactly have multiple backend connections. At least not running simultaneously, right? But if your system isn't fundamentally limited in that sense, right? There's nothing in McClim that prevents you from running multiple backends.
Okay.
And there's also nothing in McClim that.
So the architecture is set up so that you could put theoretically at application startup time, start up multiple backends to hook up to, and then provide. And the application layer doesn't know which backend it ultimately chooses, but because the way you designed how it does, it calls find port. The first backend to start up or the fallback strategies that you provided, it will know to try each of the ones that's in that list and the one that it's able to.
You could definitely set that up. I don't know for certain if there's a fallback operation baked into Clim anywhere, but you could definitely write one fairly easily.
I don't believe it should be. I think that's based on the application use case, but the ability to be able to do it is something that needs to be available via the framework, right? I mean, I need to be able to eventually say, you know what, there's a situation where I don't know where the hell this is going to be run, so I need to be able to at some point write some code to say, okay, this doesn't exist, do this next strategy, so that the application can start.
And the framework exists for that. I don't know if it's cleaned up enough that you could easily write a fallback system yourself right now, but the infrastructure is more or less there. I think there may be some extra things you might want to do for the backends to make sure that you can query to make sure our backend is doing its job properly or something along those lines. Or I don't know, maybe find port can return nil or something along those lines to indicate that it wasn't actually able to find one. It might just error though. I don't know for certain. I'd have to look.
Yeah. I haven't tried it. That's why I only brought it up.
All I know is that you definitely can interact with multiple backends simultaneously, and backends are well, not backends in particular, but ports are first class, and ports are backend specific, right?
Okay. Yeah.
So you can definitely have multiple ports, and ports are first class objects that you can pass around and choose when you spawn frames on them.
Okay, that makes
there's nothing preventing you from connecting to multiple X servers at once.
Right. Absolutely. Okay. Well, I see we went over again, but this is kind of our style. Any questions regarding profiling in general, or any other questions that we were talking about regarding McClim or anything from the audience? Michael Gargano, I see you still being on there. You have any questions? Michael Fiano?
You have to wait 15 seconds.
I was just wondering, last week, I know we talked about covering profiling, which we did, but we also talked about covering one more thing I can't remember. Does anybody else remember?
I don't remember us mentioning anything else, but I have to go back and look. I don't remember. But I was going to hold off on talking regarding the last part of Chapter 7 because I think having the profiling knowledge will help us do stuff with in Chapter 7 and at the end of Chapter 7 of Let Over Lambda. Hoyt goes through a couple of topics that I think would be cool to at least profile and see how much faster the code would be. But I need to write some examples. Like he has a section on writing, he implemented something from a guy who wrote a closure-based pointer scope example. I'm forgetting his name. If you give me just 1 minute, I'll just pull this up from the book. Yeah, Oleg Kislyak wrote on for Scheme actually an example of emulating pointers using closures in Scheme, and he wrote up. Hoyt wrote up an example of doing this in Common Lisp, and I was going to try after implementing this, which is why I didn't have a chance to do it last week. But I was going to try and see if I could take this framework that he provided and implement like a tree algorithm using it and see how much faster it would be versus the tree algorithm that's in native Common Lisp itself. And then, that requires kind of like some sort of like ability to time it and write like some tests against them, but I didn't have a chance to do that. He also brought up in later on in this same chapter an entire section on doing memory management using cons pools, and that's something that I wanted to at least us talking about, tuning the garbage collector and stuff like that, and when to use this particular use case, because it might come across as that, by doing these kinds of tricks, you're basically saying consing is actually a bad thing. Consing is not, a bad thing. It's actually very fast and it's fairly cheap, as you saw in some of the examples that we've done. It's just if you do some blatantly incorrect things in writing your Lisp programs, you could be consing too much, which will, end up calling out to the garbage collector a lot, right? And even with a tuned garbage collector, you will hit a performance bottleneck because the way you wrote your algorithm. And he gave some examples on how to set it up so you could pre-cons a bunch of cells and use them later. He calls them T-lists, from a example that someone wrote in Interlisp, apparently. It's a data structure that Warren Titleman actually wrote in symbolics. In Interlisp for the Xerox implementation. So there's a couple of things that are in here that are towards the end of the chapter that I thought, it might be good to first do some profiling and then write some examples to show that this is how much faster it would be if we actually profile it with a certain amount of samples. But I haven't had a chance to actually go through and implement some of those things. So I decided not to bring that up today. But it's certainly something that I'd like to do next week, if that's okay with you guys. Obviously, other topics that people want to cover, please send them to me on Discord or on the Functional Programming Slack, or I'm even on Twitter. Unix Nerd is my handle. Ping me, say, hey, I'd like this topic to be covered in the Common Lisp study group, and we'll add it to the list. Folks who want to give talks and other demos, obviously we're just going through some of these book examples to give some case studies, some classroom case studies for you to work on. But certainly I'm more than willing to accommodate for folks who want to show off their latest cool Lisp program that they're writing and designing so that we could discuss. implementation details, performance problems, and so those sort of things. So yeah.
May I make a point?
Yes. Go ahead.
So sort of building off what was said in the book, that I'd like to note that consing is no more bad than taking time is, right? Inherently, it just means your program is doing work.
Yeah.
The problem is when your program takes too much time or takes more time than it needs to. Similarly, the problem is that when your program is allocating too much or consing too much or consing more than it needs to, that's when your profiling becomes useful and important.
Right.
There's nothing inherently wrong about consing. There are plenty of algorithms that have to cons quite a bit. It means your program's doing work.
Exactly. And I think that's a very important thing to take home, right? Because a lot of folks are like, oh, even in like other languages, we should try not to, we should pre-allocate memory, and that way it'll be easier to actually go and retrieve. Yes, but you've pre-allocated. At some point, you've
right. You still have to con somewhere, right? And you're right. Like, it's important just to frame the discussion as consing more than necessary, or consing where we don't need to cons.
Right.
Right. Not that consing is bad. Consing is important. Consing is how we get memory to do stuff with, and we need memory to do stuff.
And it's just the same as folks who are using new or in other languages, or if you're doing some sort of, if you're mallocing in other languages, at some point you need to allocate something on the heap or even on the stack. Knowing when to do what where is a very, very important thing to know when you're designing your programs, regardless of language. So that's why when folks say these blanket statements, it's without actually framing the question, it actually does some damage to the discussion. There is a case and a time where where you need to do that. Now, again, to that point, it doesn't mean you should just write the naive implementation all the time. You should take the naive implementation, profile it, figure out if there's a bottleneck and do it, and make some adjustments later on. And if you know that the naive implementation can be improved on, then just write the improved implementation. Why write the naive one, right? That cons is a lot, and so forth. There are things that requires a little bit more engineering, not than just taking an algorithm out of a book and blindly following its implementation and then coming back saying, oh, this implementation cons a lot, that means consing is bad. No, that's not the conclusion you should come to. It's the algorithm implementation. If the algorithm may have been written incorrectly, you have to go and figure out how to tune it so that you can actually get the kind of performance benefits that you'd want.
Well said. Yeah, data structures and algorithms at the top. Choose good ones. If profiling shows that you may get a little bit performance increase by reducing consing or helping the GC out a little better, don't do that if it's going to cause you to rewrite things and take a year to rewrite for 1% change, and especially make your code a lot more unmaintainable. In the process. Work on the low-hanging fruit. See what the profiler says you should be optimizing.
Very well said, and I think that's really what the take-home message of even today's discussion is. Really, like, you have to be able to measure your program. You have to figure out where.
There's a balance between optimized code and maintainable code. The more efficient your code is, there without a question, it's going to make your code less readable and therefore less maintainable.
So you're gonna have to figure out where you can get the biggest bang for your buck. Where no matter what, you absolutely have to do it. But even there, with macros, you can hide some of that complexity.
May I make a quick correction? It's not about so much optimized code is harder to maintain. It's hand optimized code is harder to maintain. I often would argue that a more optimal algorithm can be easier to maintain in the long run.
Right.
Depends on the algorithm, of course. Some algorithms are insane.
Yeah.
Well, certainly.
But hand optimized code gets a lot harder to maintain in the long run.
Yep.
Very true. So until next week, like I said, our topic for next week right now is tentatively going to be finishing off Chapter 7, hopefully with some really nice examples with stuff that we covered today. If you guys have any ideas for talks that might want to take precedence on, let me know. I'll certainly take that under advisement. And but until I hear otherwise, this is kind of like the agenda. So I'll see you guys next week.
See you then.
See ya.